Welcome to the Content Matters podcast, where digital content and marketing pros talk shop. Tech may be changing fast, but great content is timeless. Get inside tips, trends, and practical know-how from the top minds in the digital content industry. Sponsored by Ingenix, the uniquely agile content management platform. Welcome back, everyone, to the Content Matters podcast. I'm your host, Barb. I'm glad you're all back with us today. I wanted to introduce to you Scott Hunter. He's the Director of Program Management for .NET at Microsoft. He's worked with Microsoft for over 12 years. He started out on the ASP.NET team, and he slowly started taking over responsibility for more of .NET and the tools in the Azure SDKs to the point where now he's responsible for the entire .NET platform. Scott recently did a presentation at the Ingenix user conference. Ingenix is the sponsor of the Content Matters podcast, and he outlines the future roadmap of the .NET platform. And there was so much good information in it that we thought that we'd share it on our podcast with our podcast audience. And I know that normally we talk to experts in things that are about content, the writing of content and that kind of thing. But I think that this is a great way to look at the back end of how you produce content and how important it is to have the right architecture and infrastructure in place. So I think it's going to be a really good conversation. So welcome, Scott. I'm glad you're here.
Yeah, I'm glad to be here. Thanks for having me back after the conference. I'm super excited to do the podcast with you.
Cool. So we've got a few really good questions for you, and I think we're just going to dive right in and get techie for a little while. So let's start with, if you can explain to me what the .NET Core is, and I know there's a .NET Core and there's a .NET Framework. Like, what is the difference between the two of them?
Yeah. So first off, if you're a content developer and you're new to this, all the websites in the world are built on frameworks, and there's a variety of popular frameworks. There's one that we build called .NET Framework. There's Node.js. There's Java. Those are some of the three popular ones you might hear about in tech term. And we built two of these in Microsoft. In 2002, we launched the .NET Framework. And what the .NET Framework was a technology for a developer to build any type of app that would run on Windows. So if you want to build a web app that ran on a Windows server, you could build that on .NET Framework. If you want to build a desktop app that ran on Windows, you could build that with .NET Framework. If you want to build a service that ran on the machine in the background, you could build that with .NET. And that was the .NET Framework that we shipped for many, many years. And then what kind of happened to us was we saw a change in the world. And the changes, there's a couple changes. One is the popularity of open source. Almost all of the developer technologies that exist today are open source. That means the source code is out on a public repository like GitHub. You can download, look at the source code. You can even look at that source code and suggest a change and send us a bug fix. And so that was a change we saw in the industry, was this huge shift towards open source. The second big shift that we saw in the industry was a shift towards Linux. Many of us have heard on the news and in the tech space about this operating system called Linux. And Linux is a open source free version of Unix that you can run on a variety of hardware devices. And so we saw these were two of the big changes that were happening in the ecosystem. And .NET Framework has historically always been a framework built for building apps on Windows. It was closed source. And so in 2014, we announced the beginning of building a project called .NET Core. And what .NET Core was a completely open source version of .NET that also happens to run cross-platform. So it runs on any device, whether it's Windows or Mac or Linux or Android or iOS or an IoT device like a Nest thermostat or something like that. It's designed to run everywhere. And so it's kind of our way of taking .NET and pulling it into this new modern era of open source cross-platform development. And that's why we built it.
So it's the evolution of the .NET Framework. That's what you mean?
It is an evolution, but it's also slightly different. There's parts of things in the .NET Framework. The other part of the evolution is if I go and look at the way I would build an application in 2002, and I contrast that with how I would build an application today, they would be different. The tech world is always changing. Years ago, there was this protocol that everything was using something called SOAP, and now everything is using something called REST or gRPC. And so with .NET Core, we also took a change as well, where we said we're not going to put all the older tech in .NET Core. We are only going to put the newer tech into .NET Core. So there's not any SOAPs. The SOAP tech from back in 2002 was not in .NET Core, but the gRPC and the REST tech everybody's using today are in .NET Core. So .NET Core also, just by its nature, only has the things in it that we think somebody building a brand new app today would have. And some of the reason that tech changed was in 2002, we didn't have smartphones. And now we all have smartphones. And every time you run an app on a smartphone, it's calling an API. And so it needs either a RESTful endpoint or a gRPC endpoint to talk to. And that's why that tech's in .NET Core.
Is there a reason that a developer would want to stay with using the .NET framework over, as opposed to going with the .NET Core?
What we typically tell developers, just because we build a new thing, now, developers are funny people. As a developer, I always want to use the newest stuff.
Yeah.
But then I have to go convince my boss, hey, I want to go convert this thing I've been working on for the last 5 years to use the newest stuff. And they're kind of like, well, what benefits are we going to get out of it? And most cases, you don't really gain a whole bunch by taking, if you already have an app that works, you should probably leave it where it is. And so for most of our developers, we say, for your existing applications, leave them on .NET Framework where they are today. It's fully supported and will be supported forever. .NET Framework is part of Windows. It's part of the operating system. It's not, it's like some people ask me, God, when's it going to go out of support? I'm like, it can't go out of support. Windows, it's in Windows, and Windows depends on it. So it's never going to go away. So for most people, what we say is leave your existing apps where they are. But if you build a brand new app, you should build your brand new app on .NET Core, which will give you access to all the latest technologies and all the latest standards. And you'll get the benefits of having all the source code out there and being able to run it on different devices and stuff like that. So that's kind of how we kind of divide the two.
Okay. Can you communicate across the two platforms? I guess I'd call it a platform, right?
Yeah, you actually can. So that was an important characteristic to us, is making sure that if you're a developer, we already have millions of developers that have .NET Framework code.
Right.
And so in 2016, we introduced something called .NET Standard. And .NET Standard is a kind of a spec, and it says that anything that's written against .NET Standard has this supports the APIs that exist both in .NET Framework and .NET Core. And so what this means is, if you have code, you can take your existing .NET Framework code, and if it matches to .NET Standard, there's a drop-down in Visual Studio, our IDE. You select .NET Standard, recompile it, and now you've got a piece of .NET code that can work everywhere. Not only will it work on .NET Framework, it'll work in .NET Core, and it will even work in the mobile devices for like iOS and Android. And so what we recommend our developers do is move your code to .NET Standard code, and then because it's .NET Standard code, you can use it everywhere. So that's one aspect of being able to talk between the frameworks. And the other one is, we kind of mentioned that SOAP stack before, that SOAP technology. While we don't have the SOAP technology in .NET Core contains enough of it where it can call into, so let's say I've got a server that I wrote 5 years ago, 6 years ago. It's got this WCF framework in it using SOAP. You can call that from .NET Core. So we made it where you could at least call to your existing services from .NET Core to .NET Framework. So between sharing code with .NET Standard and being able to use what we call WCF client to call into your existing services in .NET Framework, we think we have some pretty good connectivity back to between the two frameworks.
I can see a lot of developers and companies, period, happy that that's possible.
Yeah, it's actually super important. It was one of the things that, as we were building the technology, we wanted to make sure that it was easy to share code across the two divides, and then to be able to call between the two as well. So that's super critical to the product.
Yeah. So .NET Core 3 was recently released, and I was kind of looking at some of the new stuff. What's new in this version?
So .NET Core has been a journey, as we kind of talked about before. We introduced the first version of .NET Core in 2014. The first version shipped in 2016, and then we're kind of 2019 now. We're at version 3, and so the first versions of it, you really had to want to go to Core because it didn't have a lot of the APIs that existed in .NET Framework. With .NET Core 3, we think we finally have brought enough of the technology from .NET Framework in that pretty much any kind of workload that you want to build is available. So the big things we brought into .NET Core 3 is we brought in support for desktop applications. So you can now build a WinForm or WPF application. Those are the two desktop types that we have on .NET Core 3. That's brand new, and we think that's a huge piece. You mentioned before that there's some things that we don't have in .NET Core that we had in .NET Framework. And one of those was there's a technology called WCF for talking between applications. And we have a new technology called gRPC. It's in .NET Core 3. And it allows any .NET application to talk to any other .NET application over the internet. What's even cooler is the gRPC technology also works with other programming languages. So I can build a .NET Core-based application and call it from Java or call it from Node.js, and vice versa. If you have a gRPC server in Node.js, I can call it from .NET. So we think it's the best way to talk between applications because it's cross-platform. And then there's probably the most exciting piece to me about .NET Core 3 is a new technology called Blazor. And what Blazor is most of us, as we browse the web, you don't know it, but most web applications are what we call SPA, which is a single page application. And what that means is, as we started building web apps over time, we've tried to make them look more and more like apps that used to run on your desktop, which means when you click something on the screen, the whole screen doesn't redraw. It feels like you're just navigating inside of an application. And to do that, historically, you've had to learn yet another programming language or programming technology, like we call these web frameworks. And there's a couple of popular ones like AngularJS or React or Vue. And so it means most applications ends up being some language for the back end, a different language for the front end. And we're introducing with .NET Core 3 this technology called Blazor, which lets you build an application all the way from the code that runs in the browser to the code that runs on the back-end server, all in C#. We call this full stack development. But the way I think of it is any .NET web application that's built with Blazor is a single-page SPA style application. It's a modern web application, but you don't have to know any you don't have to write any JavaScript. You don't have to use a JavaScript library. It just works by default using some pretty cool technology that we have. And so I think that's kind of the future of the web is these SPA applications, and anything that my team can do to make them easier to build. If you are building a website, it's going to require less technology and less experience and less learning to build an awesome website that looks very modern using the Blazor tech. But I think those are probably my three big pillars would be the desktop tech, the Blazor tech, and a bunch of the stuff we've done to make it easier for apps to talk to each other across different technologies.
Are there a lot of developers out there who want to write cross language? Like, is that a very in-demand requirement?
It wasn't a big requirement, let's say back in 2002 when we built the .NET Framework. Back in that era, most companies would choose one single technology for their entire organization. And so it's like, okay, we're gonna use Java or we're gonna use .NET, and the entire company would write every single thing in one technology.
Yeah.
What we find today is today's developers are a little different, and in some ways it's a good change. Today, most teams will use the right tech for what they're going to build. And so it might be that if you're doing a lot of machine learning, Python might be the best choice because it has the most machine learning libraries. And so you end up writing some code in Python. And then you decide you want to build a .NET desktop application that talks to that Python thing. And so we don't see, we call this, heterogeneous application development, which is, we very rarely find a company today that is only based on one technology. Most of them are using a variety of technologies, whether it's .NET and Java. I mean, I'll tell you, in my experience, any customer that's a .NET customer probably is also a Java customer. They're using both.
Okay.
So it's more important today than it was, 10 years ago.
And desktop applications, people actually still write those? Like what are some examples of why you do a desktop app over what is, most people just write the web-based apps now?
Yes, that's a we ask ourselves this exact same question. So as we were building .NET Core 3, and we were asking ourselves, hey, should we put the desktop tech on .NET Core 3? And we ask ourselves, are people building desktop applications? And so we can look at the telemetry coming off of Visual Studio, and it kind of gives us, we can't see your code or anything like that, but we know what types of projects you open, what types of projects you create. This will probably blow your mind. We have not a single million, but multi-millions of developers today building desktop applications still.
Wow.
And I'll tell you why. By the way, when I joined Microsoft, I joined the ASP.NET team. That's the web team, the web part of .NET. And so I've been a web developer pretty much my career. And so I'm kind of a web person. But even I'll tell you, as a web person, I can still build a desktop application in about half the time I can build a web application. And so probably the most common type of customer we have is they're not going to build a huge, complicated, content management system that you might see as a desktop application. But let's say I need to build a very quick order entry form. I can probably build that in half the time I can build a web app. And so what you find is that I call them snack apps. A lot of desktop snack apps are being built today just because the technology is faster, easier to build. And then what you find is the companies with the bigger apps, they might go all the way where they have a mobile version and a web version, and sometimes even a desktop version. So you might see all those. I mean, I'll give you a great example. I don't know what you do, but of course I work at Microsoft, and so I use Office. There's a version of Office that runs on the web. There's a version of Office that runs on my desktop, and there's a version of Office that runs on my phone. And even as a customer, if I'm traveling, I'll use my phone. If I'm on a PC that I don't own, I'll use the web. And if I'm on my computer, I'll probably use the desktop application. And so some of our customers still do the same thing. Another one you'll find is some of my customers are in the financial industry, and they will build these applications that would scare you, that have maybe 100 fields that you have to fill in on screens. And desktop is just better for those very dense, pack a lot of stuff all on the screen. With web, things tend to wrap and move around and stuff like that. With desktop, you can kind of fix stuff in place. But you are right. There is, I think the majority of new apps are web apps. But there are still millions of developers building these desktop apps.
A quick pause to say thank you to Ingenix, the Content Matters sponsor. Ingenix is a leading provider of agile content management solutions. You can check them out at ingenix.com. Mobile apps are another big thing, and I noticed that you were talking about, I'm going to say it the right way, I hope, Xamarin. Is that how you say it?
The way to say it is Xamarin.
Xamarin. Oh, I'm so off base.
Yeah. So, by the way, I don't know if I would have said that right if I had not ever seen it before I said it. So I'm not going to give you a hard time about that at all. A crazy mistake. Xamarin is interesting. That's a company we acquired about 3 years ago, and what that company specialized in was building mobile applications with .NET. So today, In most cases, if you want to build a mobile application, what you have to do is you're going to build your Apple iOS application. You're going to use Objective-C or Swift. Those are the two programming languages they platform. If you're going to build an Android application, you're likely to use Java or Kotlin. So there's 4 different programming languages across those 2 mobile platforms. And where Xamarin comes to play is Xamarin allows you to use one technology, C#, or one language, C#, and one programming framework, Xamarin, across all those devices. One of our biggest Xamarin customers is UPS. So if you have a UPS app on your iPhone or your Android device or your iPad, that is a Xamarin application, which means the benefit to UPS was they wrote the code one time in C# and were able to share that code across all the devices. So it means, versus if they had gone completely native, they would have had to write a Swift version of it for the iOS device and a Java or Kotlin version for the Android device. And so, so even mobile is a place you could use .NET. And the benefit, once again, is one language, one technology, across multiple platforms.
A lot less development effort if you have to just build it once and kind of help it work across more than one application.
Yeah. Well, imagine you fix a bug once and it's fixed on both platforms versus having to fix a bug and then go, do we have the same bug on Android? Let's go check on Android. And so, important part of it, yeah.
So so there was also, I saw you have machine learning now. That's kind of nice to see.
That's a space that we've never. There's 2 spaces that I can't tell you why. We just haven't got into, but the 2 spaces are machine learning and big data that we've never had a huge .NET push in. And what kind of happened, the machine learning aspect of this it's kind of a funny story. It kind of happened by accident. The reality is Microsoft has had machine learning tech in our apps and our websites and our devices for a long time. And I'll give you an example. There's a technology on some Windows devices called Hello. And with Hello, that's when you basically, it's very similar to the Face ID that they have on Apple devices, where you basically, when you open your laptop or you open your device, the camera recognizes who you are and logs you in automatically. That technology was actually built on an internal library inside of Microsoft, built on .NET years and years ago. If you are in PowerPoint and you're building some slides for your slide deck, at some point PowerPoint will recommend, what if you theme it this way, or use this theme, or use that theme? That is some .NET machine learning tech. If you were using our search engine, Bing, there's various parts of Bing, the search engine that we're using .NET. And what happened is we the .NET team weren't really aware of this. And one day my team, or the team that built that tech, came and presented to us, and we're like, interesting. And so we convinced that team to basically take that source code they've been using for all those applications and more, and open source it, because we're in the open source era. And that was the beginning of .NET machine learning. So it's a library called ML.NET, and basically you can use hardened tech that you've been using at Microsoft for all these applications to build your own applications. But having machine learning tech by itself isn't enough. I remember I was showing the first version of ML.NET about a year ago, and one of the things I struggle with is if I'm going to go get in front of a bunch of developers and show a bunch of code, well, I want the people in the room to understand the code. And this ML.NET code was hard to understand. It was like, it was complex. And so I went and complained to my team. I'm like, I don't know if I can explain this. How do we make this easier? And so just a few months ago at the Build conference in May, we announced a technology called Model Builder. And what Model Builder lets you do is it gives you a wizard where you select common machine learning patterns, like I want to do sentiment analysis, or I want to detect some what we call regression. I want to go see if I want to predict something. And with this tool, you can basically feed it some data. It will actually build your machine learning model for you automatically, and then it will give you the C# code, the .NET code, to stick into your application to use the model it is built. And so not only do we have a machine learning library built into .NET, we also are starting to build tooling to make it accessible to more and more developers.
I like that because, I mean, yeah, it's such a hard thing to kind of grasp and wrap your head around for even probably a hardcore developer, like to make it accessible for, you know, entry-level developers, mid-level developers to be able to use it is really nice.
Yep. The joke I always like to say is, if I go stand in front of a bunch of developers and say, who wants to use machine learning? All the hands will go up. And then I say, what would you do with it? And then all the hands go down, because it's like, yeah, I want to use some AI, but what are you going to do with it?
Yeah.
Oh, I don't know. So we built an entire part of our website. If you go to dot.net, you can scroll down and click the machine learning button, and we have broken the whole space down. Let me just do it here while we're on the podcast. There, click machine learning, and I will click ml.net, and it will take me to a page that basically will give me a whole bunch of scenarios that I might want to do. I'll give you examples of these. Sentiment analysis. That makes sense. That's if somebody wrote an email to me or wrote a review, and I can tell if it's a good review or a bad review.
Right.
Product recommendation. You know, we've all gone to online shopping sites, and after you buy a few things, they say, well, maybe you should buy this too, because, you know, they've looked at what other people that buy the same things you buy. Price prediction. Be able to go and predict what the price of, say, a taxi ride is, or an Uber ride is going to be. Object detection. Look at a picture of something and tell me if it's a chair or a horse or a tree. A whole bunch of these. We have 1, 2, 3, 4, 5, 6. We have 9 of these sales forecasts broken out on a site, and we have samples for each of these for developers. And so our goal, as I said before, is, you know, make this available to more and more developers. That's
I like that. I'll have to check that out myself. So, and then you said you have the big data, the analytics component. That's Apache Spark, right?
Yeah, that's an interesting one too. So, you know, as I said, we haven't really played in the big data space. I mean, the machine learning space. And big data is the next one, and big data is actually one of the hardest ones to describe in many cases. Big data is also one that probably scares most people when you read the stuff about Facebook and Google. A lot of that is big data, but big data is, and I'll do it in contrast of thinking about some of the tools that we work at Microsoft. One of those being Visual Studio. So big data typically means you have more than 50 terabytes of data, and over time, most companies have this. I mean, Amazon's got to have tons. Imagine somewhere there's a database in Amazon that has every sale they've ever made. Other examples of big data is a weather station. Stores all the weather forever, back 20, 30, 40 years. And if you're inside of Microsoft, like I was talking about earlier, Visual Studio, it's our IDE for building applications with .NET. Well, you know, it sends us diagnostic data telling us, did it crash? Is it slow? What commands are customers running? We consider all those to be big data, because, you know, after you have years and years of that, you have a ton of stuff. And none of the tech we have out there today, like most people are used to, like relational databases, SQL servers. That's what you typically store data in. But once you have, you know, reams of that data, you no longer can query those things. And so Apache Spark is an open source project that builds an engine that's designed to let you run queries across big data. And Apache Spark historically has been written for Java developers. It itself is written in Java or Scala. And so it's written in Java. And so obviously the first customers to call it will be Java customers because it's written in the same tech. But then as Python started becoming bigger in the ML, machine learning, big data space, they added support for Python to Apache Spark. And earlier this year, I was excited to announce that we've now added .NET support for Apache Spark. And that means .NET customers can now run queries against, massive amounts of data. And what makes Apache Spark cool technology is historically a relational database sits on one computer. And so all you can do is add more memory and a bigger CPU to it. And at some point you can't make it go any faster. With Apache Spark, it breaks up your query and can spread it across multiple computers. And that we call that a cluster. And so it can utilize, instead of utilizing 4 or 8 CPUs, it can utilize 100 CPUs. And instead of using, 64 gigabytes of RAM, it can use 30 terabytes of RAM across all those machines. And so I'm excited that .NET customers can for the first time start actually talking to a big data system like Apache Spark without having to drop down to Java or Python. So one of our goals with .NET is to make it where your .NET code can run on all the devices, and you don't have to leave .NET to do any of your workloads.
It'll be interesting to kind of see some of the big enterprise use cases that come out as they start really leveraging a lot of that technology.
Yeah, what they'll do is they'll typically the first thing they'll do with the big data thing is, like, imagine you're an Amazon.com. We were talking earlier about ML.NET, product recommendation. Well, I can do product recommendation by looking at 100 customers, or I can do product recommendation looking at 100 million customers. And that's where big data comes to play, where you go and take that data from those 100 million customers and run it through a machine learning algorithm. That's kind of how the whole thing settles out. So it's going to be very interesting. If we did this a year from now, it'd be interesting to see what customer success stories we have.
Absolutely, yeah. I can just imagine how much more personalized or customized the customer experience is by being able to access all of that data and take advantage of it.
Yes.
So okay, so you're talking cross-platform, stay on .NET. The other kind of development approach that is pretty popular today, or people are talking more and more about, is that idea of microservices. And microservices are like building your application in small components, right? So can you do that with .NET?
That's a great question, and I'll highlight a little bit more about what you said there, which is when I started programming a long time ago, sadly, we used to build the term for the applications we built in that era. This is 10 or 12 years ago. They're called monoliths, and that means that everything is packed into one single application. And the challenge you have with a monolithic application is, first off, it's the negative of building a monolithic application is, because it is a single thing, there's no way for one part of the team to try to go and go faster than the rest of the team. Everybody has to kind of stay in sync, meaning that, hey, I'm going to write brand new UI to make this big application look so much better. But I can't do that without also compiling all the other parts of the application at the same time. And because everybody's working at the same time, it ends up breaking a whole bunch, because I make a change, which then breaks your part of the code, and they're called monoliths because it's one big massive application that everybody works on. And so this notion of saying, what if we break applications into a few pieces? And it's kind of funny to watch these journeys, because a couple of years ago, the first people that started trying to do the microservice thing went crazy, and they broke their apps up into like not like 3 or 4 pieces, but more like 30 or 40 pieces. And then they couldn't manage all the side pieces that they built. But the intent here is, really what you want to do is you want to break the app into a couple of logical pieces. And this is where the term microservice comes from. instead of having my services be part of the big web application or desktop application or mobile application, I can break those off into their own components, and then my developer team can work on that without risk of breaking the bigger part of the application. And that's the term microservice. And so it's a popular term that you hear a lot today. And .NET was born in the monolithic era. Java was born in the monolithic era. But we've all restructured our frameworks now, where if you want to build a really small application that does a really small piece of work, we've made that very simple for you. So .NET Core 3 actually has some new stuff inside of it that's meant solely for building these type of applications. We have a new app type called a worker. And what a worker is a very small application that kind of runs as a service. You know, imagine your phone calls to some API. And it used to be that if you want to build an API in .NET, you got tens of 20 of files and stuff like that. With these workers, you can actually knock an app down to, like, if you wanted, maybe even one file. And so the entire app fits in one file. And so we've done a lot of work to make it where you can shrink a .NET app super, super small into less pieces, less files, if you want. But as I said, typically a microservice ends up being more like a macro service, because if you really only put one API in each microservice, you know, you would end up with like 200 microservices, and then you would struggle to maintain and publish those things. And so what you typically will do is say, hey, these are all the APIs around logging. We'll make that into a microservice. These are all the APIs around payments. We'll put those into a microservice. And these are all the APIs around the products in my catalog of things I'm selling. They go into one microservice. So I end up with like 3 microservices and then a web front end. But by breaking the app into 4 pieces, each of those teams can work independently without risk of breaking the other teams. And so the hope is that it lets teams move at a faster pace than they have historically.
I think that makes a lot of sense. I know there is a lot of discussion around how microservices, people kind of take it to too much of an extreme, and it's not a viable architecture to work with. But it sounds like you just have to think about it in the right way and design that architecture to make it in a way that really makes sense, other than just breaking everything into its own little microservice.
Yep, that's exactly how I think of it. And super excited about all this tech. It's so good.
Yeah, there sounds like there's so much stuff in it. I was a developer, I'm going to say 12, 13 years ago maybe, and we didn't do any of this stuff. So this stuff, the more I look at it, the more there's a part of me that wants to go back into development, but knows that I'd be crazy because I would never be able to do it today like I could have back then.
I would challenge you opposite. I would say that it's probably easier today than it was. Development goes through weird cycles of it goes through being easy to hard, back to easy. In .NET, we're trying to go back to easy. We went through a phase where, you know, we have a bunch of talented engineers that know how to do crazy stuff with code, and sometimes, you know, part of my job at Microsoft actually, and my team's job at Microsoft, is to make sure we don't ship complicated products. We have, you know, awesome engineers that want to do cool engineering feats and stuff like that. But our real goal is, from my team's perspective, is my team actually kind of is the watchdog on the product to make sure that it's easy to use. And so I would hope that if you tried the tech today, you would find it easier than when you last tried it.
I might have to do that just to do it. So it's interesting. You talked about how, you know, there used to be the battle between Microsoft versus Java. But there's was always a battle between open source versus proprietary. So it was like, you know, Microsoft against the world in some ways, right? But Microsoft has really kind of adjusted its view about open source. But not all of it's open source either. Like there are parts that aren't. So why do you think Microsoft, or you should know actually why you chose to kind of come into the open source, you know, way of sharing your code, and what parts aren't open source?
Yeah, so it's a good question. So, you know, Microsoft historically was, if you go back in time, was anti-Linux, Linux is a free version of Unix, an operating system, and Microsoft was anti-open source. I'm not going to, try to go and diagnose why it was that way, but I can tell you why we're in a different place today. So I joined in 2007 on the ASP.NET team, and one of our goals when I joined with 3 other good friends of mine, and we're all like, our first thing is we have to open source .NET, and then our second thing was we have to make it work cross-platform. And so the open source thing, I can give you some reasons why open source is important. And I'll do it in the context of, say, .NET. So we opened open source .NET in 2014. And there's a couple things that customers like about open source. Sometimes there's technologies that I stop investing in. But if they're open source, if a customer really cares, they can go fix a bug themselves. So that's one aspect of open source. Some companies believe that if they build on top of open source, as I said, they won't get stuck. Where we move somewhere else, and at least they have the code, and because they have the code, they can take it forward themselves if they had to. But where open source gets really crazy is, we open sourced .NET in 2014. Today, more than half the contributions to .NET don't come from Microsoft; they come from the open source community. If you think of me, my team, I've got a fixed set of engineers that work in .NET. And you might file a bug on .NET. And when you file a bug on .NET, we'll look at the bug and we'll go, interesting. We think that bug will affect 100 customers, but we're not going to fix it. I might have another bug that I know is going to affect 20,000 customers. I'm going to fix that bug. And that's just because I only have a fixed number of people and I can't fix everything. Or if I fixed everything, I would never add anything new. And so open source allows the community to go, that same bug I wouldn't fix, well, the open source community will and has and can fix. And so, versus my fixed number of developers, if I'm open source, suddenly I'm getting support from hundreds, if not thousands, of other developers as well. But not only can developers learn from my code, they can actually help me by fixing bugs and issues in my code. And so it makes the development team that works on our product just a much bigger development team. Another aspect of open source that's really interesting is, if I go back to that closed source proprietary Microsoft time. Well, back then, if you were a customer, you would have no idea what the next version of our product was going to do, because we didn't want to tell anybody, because that was a secret, and we didn't want anybody to know, so our competitors couldn't do it first. If I go to the open source world, actually my roadmap is actually in GitHub. You can go look at GitHub and see what's planned for the next 3, 6, 12 months potentially, by looking at my roadmap. And so as a customer, it makes a customer much happier to go, I can actually see the future where this is going. I'm not afraid of this anymore, because I know that this big change is going to come, because we're being transparent and open about it. So those are some of the benefits that I'll give you another great example for anybody listening to this. The best way, if you want a job in technology, one of the best ways to get a job in technology is to go find a couple popular projects for the company that you want to go join, and go file some issues, go fix some bugs, go make some pull requests. There is nothing better than that blows a resume out of the water, because the company will go, oh, I can see these contributions you made in my source code. So I can see that you're a developer that understands how to use GitHub, how to use .NET, how to use the tools. There's no better resume than doing that. And we've hired people in my org that we found, through those kinds of mechanisms. The change from Microsoft, from closed source to open source, a lot of that is just the way that the world has changed. I think of a great example of this is, if you go back to the Microsoft 5 or 6 years ago, or even further back, let's say 10 years ago, we were a Windows company. Everything we did revolved around the Windows operating system, which is fine. But if you look at the modern world, you probably have an Android phone or an Apple phone. You might have a tablet. The reality is we all carry a whole slew of devices. And so the idea of everything being the same operating system just doesn't make sense anymore. Microsoft moving to be a cloud company helped as well, because once we're a cloud company, we are agnostic to all those things. We don't care anymore. If, like I'm the .NET team, I don't care if you use Java. I hope my product's better than the Java product, but there are things that Java's better at than my technology. There's things that Go is better at. I embrace that today. I don't fight it. And so I think the movement to the cloud kind of changed everything, because once you're in the cloud, we don't care if it's Windows, we don't care if it's Linux, we don't care if it's Java, we don't care if it's .NET. And so as we moved away from being a Windows-centric company, it just led us away from being a proprietary closed source company. But even Windows is starting to open source parts of Windows, which is super exciting. The Windows team, I don't know if you know this, you can actually run Linux on Windows now. We actually have something called you can open a Linux command prompt on Windows. We have the Windows terminal. There's an open source version of that that's being built in the public. So even the Windows team you're seeing is now shifting. It's kind of a way that the development has just changed, and we all are embracing this.
It's definitely lots and lots of changes, and I mean, and certainly since you've been at Microsoft, there's just been so much that has changed. It's kind of cool to think about how much. Yeah, I really like what they're doing right now. I think I can see developers being really happy about it, and because it broadens their horizons much more as well.
Yeah, yes, it's a great time to be here. I am so excited to work on this tech for all my customers, and yeah, it's just a great time.
Cool. Well, thank you, Scott. This has been really interesting. Like I said, you've made me want to go back and pull up my development skills again and try some new stuff. So I'm you never know, I might actually try and do it.
Please do. And if you do, reach out to me. I'm happy to help.
Cool. Thanks. So thank you, and thank you everyone for listening to the podcast. On behalf of our sponsor Ingenix, we're glad that you came and listened today. We invite you to kind of subscribe to our podcast on Anchor or Apple Podcasts, or probably a number of other podcast platforms, and join us on Twitter at Ingenix, and you can carry on the conversation. That's all for today, so thanks and have a great day.